We now turn to tests of mean differences. Again, we'll first review some of the statistical procedures that we've already presented and talk about a few advanced topics. Importantly, remember, all of these procedures deal with the relationship between x and y, and the analysis depends upon the number of x's and the number of y's, the number of independent variables and dependent variables, and the levels of measurement associated with the x's and the y's.
We'll start with one that you should be familiar with, the t-test, the analysis of variance. And if you'll remember, we looked at analysis of variance with one independent variable, and then we looked at analysis of variance with more than one independent variable called factorial ANOVA. A new one now is the analysis of covariance, ANCOVA. In this case, we will adjust the dependent variable on the basis of a predictor variable. MANOVA is one that we've already looked at, but now we're going to add MANCOVA, which is similar to ANCOVA in that we will adjust the outcome variables based upon a predictor variable.
We'll next summarize the nature and number of variables and what analysis might be conducted. With the green boxes on the left, we've identified t-test, analysis of variance, and MANOVA. The commonality amongst these tests is associated with the x's and the y's. The x's, or predictor variables, the independent variables, are categorical, and the single outcome variable is continuous. So we've indicated next to each test the number of independent variables x and the number of dependent variables y's.
In the t-test, you have one x variable and one outcome variable, y variable. Analysis of variance, you can have more than one independent variable and one dependent variable. In MANOVA, you can have either one or more independent variable and you have more than one dependent variable.
So there's some commonality amongst these tests. Similarly, in the next slide, there's some commonality about analysis of covariance. In this case, the x variables or predictors are categorical and continuous, and the y or outcome variable or variables are continuous. Importantly, with analysis of covariance and MANCOVA, you are adjusting the y variable by some other factor that you think is associated with that. For example, if you're studying the relationship between physical activity and health outcomes, you might want to covary or adjust for age, because age is related to how much physical activity one engages in and health outcomes. So analysis of covariance adjusts for age in that situation.
Notice the only difference between ANCOVA and MANCOVA is both have more than one independent variable, but in analysis of covariance there's only one outcome variable, and in MANCOVA there's more than one.
As we did in the correlational summary, this figure summarizes the particular test that you would use, whether it's t-test, ANOVA, ANCOVA, MANOVA, or MANCOVA, and the number and nature of the x's and y variables, x being the independent variable or predictor variables, and y being the outcome or dependent variables.